Hello and welcome back to the wonderful world of polygons on the coordinate plane. This section is going to start on textbook page 705 and go through textbook page 708. Please be sure to make sure that you're writing everything that you see on the screen, that you're following along, and that you're correcting your work as we go. Let's get started. Here on textbook page 705, you see a rocker in the bottom right corner. So if you see a rocker, you are probably on the right page. All right, it says scan the rest of the lesson. List two headings you would use to make an outline of the lesson. And we're not going to get too out of control here. As you can see, we are going to find the perimeter and find the area. And we're talking about polygons still. But this time we're going to use a little bit different of a method to getting there. We're going to be using the coordinate plane. So let's go ahead and check that out. It says to graph the points on the coordinate plane to draw a map of an outdoor stadium. Complete the table to identify each shape. So off to the side, I want to just go ahead and have a little reminder session for you about the X and Y coordinates. So when you see them like this, so off to the side, you just want to go ahead and write this little note here. So when you see them in a parentheses like this, like you see 2, 6 being the first one for the stage, remember that the X coordinate comes first and that's how you move along the X axis, which is right here. If you watch my red pen, right there. So I don't want you to circle that on your page. I'm going to go ahead and erase it now. I just wanted you to see that that's the X axis, and right here is where you're going to find the Y axis. So again, don't circle that on your page. That was just so that you could see. So, and I want you to have that note out to the side as you're doing those. So what you want to do now is go ahead and plot all of the points for the stage, and then you're going to write what type of shape it makes. So I'll start that off for you. We're going to go ahead and plot 2, 6. So we're going to go over 2. And we're going to go, let's go ahead and zoom in on this a little. All right, we're going to go over to the right 2, and we're going to go up 6. So right here will be our first dot. And there we go, I might need to, okay. Then we're going to go over 2, and we're going to go up to 9 for our second dot. Over 6, and we're going to go up to 9. We're going to go over 6 and up to 6. Okay, and as you can see, I've plotted the rest of the points there for the stage. So now what you're going to want to do is you're just going to connect those dots. So you're going to start from that 2, 6 point, which was right here, and we're going to go ahead and go up like that. Connect it to the next one. Whoops, the next one. Let's make those straight lines. It's very important that you try and make your lines as straight as possible. If you're not good with straight lines, then you want to get a ruler out. All right. So let's see if I can make that a little bit straighter. Okay, perfect. So now you want to go ahead and write what shape this is. So if you look, this has 1, 2, 3, 4, 5, 6 sides. So this is going to be a hexagon. So now I'm going to go ahead and use purple to do the bleachers, and then I'll use a different number for the different color for the concession stand. So go ahead and plot all those points now and then press play on the video again. So as you can see, after I plotted the next one, that the purple one makes a rectangle. All right, now as you can see, I went ahead and plotted those last points, and the green makes a square. So let me go ahead and zoom back in there. So now you can see we've got the hexagon, the rectangle, and the square. And then it says find the dimension of the bleachers. So you want to look back up at the bleachers. In my figure here, it's going to be the purple figure. So the dimension would be found by counting the boxes from top to bottom and from right to left. So let's go ahead and do that. So when you count the boxes up and down, you get 4. So we know the height is going to be 4. And from left to right, you get 2. So the length is going to be 2. Now this book switches it around a lot with the length and the height. So if you get the 4 and the 2 interchanged here, that's okay. That is definitely okay. So now it says the length of the line from point 26 to point 29 is 3 units long. So now we're reading this problem. We've got 3 units long here, and then we've got a set of points. Okay. How can you use the y coordinates to find the length of the line? So now we want to think about that. We've got the y coordinates, which are the 6 and the 9. So if the y goes from 6 to 9, 9 minus 6 would give us 3. So isn't that going to be the length of the line? Okay, so you can see on this line here, I wrote subtract 6 from 9. The length is 3. So that's how we can use that y coordinate to find that. let's go ahead and check out the next page here. Now we're going to be looking at textbook page 706. So at the top of the textbook page, you should see find the perimeter. So again, it's going to give you a little note here off to the side. It says perimeter and area. Remember, the perimeter is the distance around a closed figure, and the area is the number of square units needed to cover the surface enclosed by a geometric figure. So that's a whole lot of blah, blah, blah. But what you want to make sure that you know is that the area, and we're going to write this here, hold on 1 second. So remember, we're going to have this little diagram here, or it's the one that I showed you before. So this little rectangle that I've made here, this is going to represent my backyard, okay? So in my backyard, I've got the grass. See all my grass? I would love to see a picture of your grass in your backyard. So this is all my grass. So the grass is basically the equivalent of the area. So that's the amount of space or the number of square units needed to cover the inside of the figure. But then you have the distance around. So I'm just going to draw a little arrow here. Now we're not going to draw it all the way around just like that, because I want you to understand that, just draw it like that and then like that. I want you to understand it's that white line around. So you're going to pretend like the yellow is the fence, and that represents the perimeter. Okay, so you want to finish that little drawing there. So you want to pretend like you're putting a fence around your backyard. The fence is the perimeter, and the grass inside is considered the area. So at the top it says, find perimeter. It says you can use the coordinates of a figure to find its dimensions by finding the distance between 2 points. So we're going to talk about using the coordinates to find the distance between 2 points. To find the distance between 2 points with the same x-coordinate, subtract their y-coordinate. To find the distance between 2 points with the same y-coordinate, subtract their x-coordinate. So I want to just take a second off to the side here to go ahead and write a little information about what we just read. So what we just read was that, we can find the distance that the opposite coordinate is if the first coordinate is the same. So if your x's are both the same, you can find the distance of the y by subtracting or finding the difference. So let's go ahead and apply that. A rectangle has vertices A to 8, which let's go ahead and cover that right here. So see that A right there? You don't need to circle it. I'm going to erase it. Just want you to see where we're at. A is 2, 8, B 7, 8, C 7, 5, and D 2, 5. So off to the side, and you'll work right here in your work area. I want you to do this work right here. Oops, hold on 1 second. Sorry about that. I got a phone call at the same time that I was making the video. So right over here on the left in the work zone is where I'm going to want you to do your work, but I'm going to go ahead and do my work in the black area because it shows up a little better. So first and foremost, when I'm reading this problem, I want to make sure that I'm picking the important information out and the coordinates that go together. So what I mean by the coordinates that go together is we need to make sure that we pick two coordinates that we're going to compare that have either the same x-coordinate or they have the same y-coordinate. So that's the specification of being able to do this, to be able to find the side length based on this. So let's go ahead and look and see in the problem. We've got A, which is 2, 8. And we've got B, which is 7, 8. So I'm going to write these up here. So we've got A. Let me make that a little brighter. Okay, so we have A, which is 2, 8, and B, which is 7, 8. So again, the stipulation was, notice that the 8 right here and the 8 right here, oops, I'm kind of off the page here. Whoops. The 8 right here. Notice that those two 8s are the same. So that's why we picked that side length, A and B. Now we can find the difference between... Let's go ahead and write this here. So now we can find the difference between this 7 and this 2 because we know the 8s are the same. So 7 minus 2 is going to give you 5. So we know that that side length right there, hold on, let's back that up. Right here in green, that's where we got the side length of 5 because we compared 2, 8 and 7, 8. And since 8s were the same, I'm going to say that one more time, the 2 and the 7, you can find the difference. So let's go ahead and look at the next set. All right, so now we're looking at the points C, which is 7, 5, and D, which is 2, 5. So let's go ahead and write that over here to the right. Okay, now actually you're going to notice that I erased the bottom green circle, and I did that on purpose. So you want to erase your bottom green circle because the bottom green circle goes with the AB line. See how we compared A and B? Now we're going to use the yellow to compare the C and D line. So we've got 7, 5, and 2, 5. So remember that stipulation that has to be met is you have to have the same coordinate. So we've got the same Y coordinate here, Y coordinate there, and then we find the difference again. 7 minus 2 equals 5. So that is in fact where we came up with that 5. So now we need to compare the other lines. So this was the AB line, this is the CD line. Now we need to compare A and D. So now we're going to go ahead and look at points from at line from A to D. So you can see that right here, A to D. So let's go ahead and look at those coordinates. Remember, the A coordinate was 2, 8, or 2, 8, and the D coordinate was 2, 5. So notice that what do we have in common? We have the 2 and the 2 in common. So now we can simply find the difference. 8 minus 5 equals 3, and that will give us the side length. So that is where we get this 3 right here from. And last but not least, we are going to look at this line from B to C. So we're going to go ahead and write our points for B and C. So as you can see, I've written the points here for B and C. We have 7, 8 and 7, 5. So again, we have our 7s in common. You want to make sure that happens first. And then we can find the difference between the 8 and the 5. So we're going to have 8 minus 5, and that also gives us 3. So now that is how we found this 3. So now what we've done is essentially just using the points. Now obviously we can see the shape here, but even if they had just given these points in a word problem, we should be able to draw the shape and we should be able to find the length of each side. So that's what you've done here. And the last step is going to be to find the perimeter. So now, of course, the perimeter is going to be the P equals, we've got this side length of 5, this side length of 3, this side length of 5, which I should put in white, and this side length of 3. So I'm going to erase this really quick. This 7 minus 2 equals 5. It's still going to be 7 minus 2 equals 5. But we're just going to do it in white. 7 minus 2 equals 5. And so that other side length there. So now we're just going to add those up. 5 plus 5 plus 3. Let me go backwards. I'll go sideways here. Okay, so you can see we've got 5 plus 5 plus 3 plus 3, and we get P equals 16 units. So now even though the perimeter portion is the only thing I have in the circle, remember you shouldn't have a circle on your page on the left-hand side, and you should have all of the work for each one of the points over there in the work zone somewhere. If you do run out of space, you could always use the space underneath the graph if you needed to. Okay, so here we go with example 2. Now remember in the last example I said we don't even really need to see the shape, even though we could in the last one. All we need is the points. So let's first start by listing the points. I'm going to list them, and I'm not going to have them in any particular color, so you should do the same. All right, so I went ahead and listed the points here, and I did not put them in any specific color. And the reason I did that was so that we could look at these points all together. It's easier for us to pick out the ones that share the common X and the common Y coordinate. So let's go ahead and work with one side length at a time now. Now in this example, off to the side, I do want you to write this. If you have colors, that would be great. So we're going to identify first the line, and we're going to write that as line AB. And what we're talking about is line coordinate A, which is right here, and coordinate B, which is right here. So line AB is going to be, so I want you to set it up like this. Line AB, and you need to have the line over it, is going to have the coordinates A, 2 and 1, and B, 2 and 5. Then I would like you to circle just in your pencil the 2. This is confirming that you have 2 points that have the same X coordinate. Now all we need to do is find the difference. So we're going to use that 5 right there and the 1 right there. So 5 minus 1 equals 4. Notice it doesn't matter which one we use first. We're just finding the difference. So it doesn't matter. We wouldn't have to take 1 minus 5. So now we have one side length of 4 units. So we can go ahead and put a little box around that. Now let's go ahead and look over here and let's identify another 2 points that have the same coordinates. Now if you look at B and C, notice the 5s. So let's go ahead and do line BC right here. So line BC is going to be set up like this. B, C. So B is 2, 5, and C is 4, 5. So now we want to circle it. You can circle it in pencil. I'm circling it in white. 5 and 5, you want to confirm that those two are the same. And then and only then can you find the difference. 4 minus 2 equals 2. So now you have a side length of 2. Let's go on and do the next two lines. The next line that I'm selecting is line CD. So coordinates C and D I'm going to write right here. And so as you can see, the reason I chose C and D is because C and D both share that 4. So now in white, I'm going to circle the 4 and the 4 because I'm confirming that they are the same. And then we're going to go ahead and do 5 minus 1 equals 4. So now we have another side length of 4. And last but not least, we have side length AD. And you want to have the coordinates for A and D right here. Now you want to make sure that you're looking because see, the reason it's A and D is because they both share that 1. So now we're going to take, I'm going to take my white, and I'm going to circle the 1 and the 1. So now I can find the difference. And I take 4 and subtract 2, and I get 2. So in our brains, we should be able to start to think about what type of figure this is going to be too. So you have, and it does say then find the perimeter of the rectangle. So now we know each one of the side lengths. I'm going to circle these in a very bright color. And as you can see here, I wrote 4 plus 4 plus 2 plus 2, because those are all our differences that we found, equals 12 units. You do want to have units. Right, so now you want to pause the video and you want to see if you can do this on your own. Now it's very important that once you play the video again, that you correct any of the work that you don't have. I want you to set it up exactly like we did it in the last problem. So as you can see here, I pulled out all the coordinates first, wrote them in some neutral color right here, and then I showed all of my work for A, AB, BC, CD, and AD. So you want to go ahead and do that as well right here on example A. And really quickly, just to remind you, it says use the coordinates to find the length of each side, then find the perimeter of the rectangle. So you know you're looking for a rectangle, which has obviously 4 sides. 2 of each are the same size, the same length, and then you're going to add up each of those sides. So let's go ahead and do that now. As you can see, I went ahead and set up line E and F. So as you can see, point E is 3, 6, and point F is 3, 8. So I've circled the 3's in a neutral color, so you can use pencil to do that. And then also you want to use pencil to go ahead and find the difference, which is 8 minus 6. And again, it doesn't matter which one is on the top, which one's on the bottom, which one comes first. That doesn't matter. So 8 minus 6 is going to give you 2. Okay, so now I went ahead and did the work for line FG, and I just want to point out at this point that because you know you're finding the length of a rectangle, and you know that 2 of the sides are going to be the same as one another, and 2 of the sides are going to be the same as one another, really, you've really identified that now. And the way that you did that was you found the commonality here with the 3's, and then you found the commonality here with the 8's. So you have one of each side. So you know that the side across from the 2 is also going to be 2, and the side across from the 4 is also going to be 4. But I do want you to go ahead and do the rest of the work for this just to make sure. Okay, so I went ahead and finished up the work for the last 2 lines. So now, as you can see, we're going to go ahead and zoom in here. I don't know if you can see the zoom or not, but we're going to go ahead and add the perimeter right here, which is P equals 4 plus 4 plus 2. Plus 2. So 4 plus 4 is 8, 9, 10, 11, 12. So our answer here is going to be P equals 12 units. So for B, I'm going to have you do something a little different. Now that you've worked through the whole problem, I'm going to just let you work from B instead of having to list all the coordinates. So let's go ahead and work from B, and we'll go, okay, line, but we'll still show all the other work. We just won't write them all out. So line IJ is going to be like this. And again, before we actually jump into it completely, it says use coordinates to find the length of each side, then find the perimeter of the rectangle. So again, they told you it was a rectangle, so that means really you're only looking for 2 of the side lengths, and then you can just multiply each of those by 2. So once you get really familiar with how to work through these, you can go ahead and feel comfortable doing that. So let's go ahead and go from here. Right, so now we're going to go ahead and look at points KL. So you have K, which is 8, 9, and L, which is 8, 4. Then you're going to circle those 8's because that's what's common, and then you're going to find the difference between 9 and 4, which is 5. And then you're going to find the points I and L, which are 1, 4, and 8, 4. Again, the 4's are common, so you want to circle those. and then 8 minus 1 is what you have left outside the box, which is going to give you 7. In pink, you can see that I have outlined the 4 pieces of our rectangle, the side lengths for each of those. So up top, you're going to see me write P equals 5 plus 5 plus 7 plus 7. So I'm going to get P equals 24 units. Now you should be looking at textbook page 707. At the top it says each grid square on the zoo map has a length of 200 feet. Find the total distance in feet around the zoo. So when the x-coordinates are the same, subtract the y-coordinate, and when the y-coordinates are the same, subtract the x-coordinate. So what they've done here is they've taken 10 plus 7 plus 3 plus 4 plus 4 plus 3 plus 7, and they've got 42 units. So basically they use the same techniques that we did before to find each one of the side lengths. So you just want to go ahead and take a look at those. I'll zoom in a little so that you can see. So for instance, we would look and we would see, okay, the 10 right here and the 10 right here, and remember the 7 minus 0 would leave you with 7. So that side length from here to here is going to be 7. And so on. So that's how they did that particular problem, and then they found that it was going to be 42 units. Now the last piece of that particular problem says to multiply 200 feet by the total distance, which was that 42 units. So 42 times 200 gives you the 8,400 feet that they got here for example 3. So you should start getting pretty good at this. If you look at the rhinoceros in the aquarium, notice the 3's are the same, and 11 minus 7 gives you 4. So that means that is a side length of 4. Then notice the aquarium and the tigers, the 11's are the same, so 7 minus 3 is 4. So that length is 4. Then from the elephants to the tigers, notice the 7 with the y-coordinate is the same, so 11 minus 7 again is 4. And so from the gorilla, I'm going to erase this pink right here so I can actually see everything. From the gorilla to the tigers, they don't have anything in common. So I want you to notice that. That's very, very important. From the gorilla, which is 710, to the tigers, which is 11.7, you can't find the distance there. So that's why you can't do that. But what you can do is do from the gorillas to the elephants. Notice their x-coordinate is the same. Then you're just going to subtract the 10 minus the 7, and you get 3 for this particular length right here. 3. Let me actually erase this so it's not confusing. Okay, 3. So that one is 3. Then we go from the monkeys and the gorillas, and 10 is the one that they share, so that means that this up here is 7 because 7 minus 0 is 0. And then to go from the monkeys to the entrance, notice they share the zeros for the x-coordinate, so 10 minus 0 is 10. So that's why that side length is 10. So from the entrance to the reptiles, they share the 0 and the y-coordinates, so the x-coordinate is 7. Then from the reptiles to the, it looks like, rhinoceros, they share the 7, so that means that this is the 3, because 3 minus 0 is 3. So now you found all the side lengths, and that's where they get all these numbers right here. So you just want to maybe play that video back a little slower, go back and just make sure that you know how to identify each one of those side lengths. So now this is another one of those two-part problems. So for the first part, it says the coordinates of the vertices of the garden are 0, 1, 0, 4, 8, 4, and 8, 1. So first you need to find out what each length is. Then the second piece says if each unit represents 12 inches, find the perimeter in inches of the garden. So it is going to be a two-part problem. So first let's go ahead and find each side length. All right, so as you can see here, I've labeled each one of the points. So we've got 0, 1, 0, 4. That length is going to be 3, and then 8, 8, and 3. So now we're going to have to first find the perimeter. So let's do that here. Okay, so we found out that the perimeter is 22, but keep in mind that's not our final answer. So you don't want to put that on the answer line. We want to use that 22, and we want to say, okay, if each unit represents 12 inches, what's the perimeter in inches? So now we need to take the 22 and multiply it by 12. Okay, so as you can see here, I've done the math on the right side in that light purple color. So now we are going to get that the perimeter is going to be a total of 264 inches. So you can put that right there. All right, so here you can see find the area. And what they've done here, this is what you call a composite figure, really. So you want to write composite figure. And what that means is they've taken two polygons and they've stuck them together. So when you're working with the composite figure, you just want to make sure that you're using the formula for each one of the areas separately, and then you add them together at the end. So here they've identified the rectangle. So notice the rectangle right here. I'm just going to outline it in green. And so then they used the formula for area of a rectangle, which is length times width. So again, I want you to first identify the shape, area of a rectangle, then show me the formula for area of a rectangle, and then substitute, which is area is 5 times 2 or 10, and then the solve. So the only difference I would do is I would do area equals 10 right there. Then for the area of the trapezoid, it's going to be the same thing. You're going to use the formula, and you're going to substitute, and you're going to solve. So let's go ahead and try one on your own. All right, so now it says find the area, so remember you're looking for area, in square units of the figure to the right. So remember that figure to the right is going to be a parallelogram, so let's go ahead and write that. So that's the first piece. You want to identify what you're working with, area of a parallelogram. You do need to have that, it is required. Then the next piece is going to be to write the formula. Remember the area of a parallelogram formula is the area is equal to the base times the height. Now comes the interesting part. We're going to go ahead and find out what those are. Remember with the parallelogram that you need to find the height. So that would be 1, 2. So do you see that there? That's going to be 2. And then the base is going to be 1, 2, 3. So hopefully you can see that right there. So that's going to be 3. So now, let me go and clean that up a little bit. So now that you have the base and the height, you're just going to plug that in here. And just like before, it's important that you're substituting in the correct spot. So first, we're identifying area of a parallelogram. Second, we're going to write the formula, area equals base times height. Third, we're going to actually find the dimensions on the grid there, which we did. Fourth, we need to substitute. So notice my 3 is my base, so I want to make sure that goes directly under the B, and the height is 2. And then finally, we're just going to solve. So here you'll see the final answer, which is 6 units squared or 6 square units, whichever one you prefer. Now we're looking at textbook page 708. We are in the home stretch, ladies and gentlemen. Let's go ahead and try and make our way through this last example. So for the example here, you can see it says a figure has vertices, and it gives you the vertice points A, B, C, and D, or I'm sorry, A, B, and C. Then it says to graph the figure. So the first thing that you need to do is graph the figure and classify it. So then you need to tell me what it is and then find the area. So I'm going to show you these steps here. All right, so off to the right, I have written the steps that you need here. It says use points to graph, so that you would graph each one of the points. Write the type of polygon. You need to identify that it's a triangle, or a right triangle rather, because it does have that 90-degree angle. Determine the side lengths. In this case, we only need to know the base and the height. You don't need to know the hypotenuse, which is the from A to C. You don't need to know that length. And for number 4, it says to write the formula. So that's what they've done right here. Area equals 1/2 base times height. Then substitute, that's what we need to do, that's what they've done rather right here. And then solve, that's what they've done right down here. And then it says triangle ABC has an area of 4.5 square units. So that's going to be your final answer. All right, hopefully you've worked this problem out. The first thing you need to do is graph the figure. So you need to plot the points. Let's go ahead and show you that now. So as you can see, I've plotted all 4 points. Now we're just going to neatly try and connect those dots with the best straight lines we can. And if you're not good at straight lines, then you want to get a ruler out so that you can do that. Then we need to classify it. So let's think about that. This is obviously going to be a trapezoid. So that would be the first part of your answer, trapezoid. Then it says to find the area. So we need to have our formula for area of a trapezoid. We're also going to write area of a trapezoid. Okay, as you can see, I went ahead and wrote the formula for area of a trapezoid because that's our very next step is to write the formula. Then we would normally go into our substitute stage, but we need to know what the side lengths are. So now we're going to need to go back to our graph here so that we can find out what those side lengths are. So let's look at our points to see what they are. All right, so I went ahead and went to this slide so that we could get a better look here at our trapezoid. So we could even find the side length just by counting. So we have 1, 2, 3, 4, 5 for one of our bases, and that's just by counting. 1, 2 for this base on the top, and we can find our height, 1, 2, 3. So we could use the method with the points, but we don't even really have to because now we know it's 2, 3, and 5. So let's go back to this one and let's label these guys 2, 3, and 5. Now we're going to substitute them into the formula. Okay, so as you can see, I substituted all the pieces in. Remember that our next step is going to be to start to solve the problem. We need to do the parentheses first. And as you can see, we get an area of A equals 10.5 units squared. Now, normally I would say you want to go in order with the order of operations, the 1/2 times 3. But once you have 1/2 times 3 times 7 on this green line right here, you just want to keep in mind that because of the commutative and associative properties, you can flip-flop those numbers around. So 7 times 3 is 21. It's probably going to be easier for you to find half of 21 than finding half of 3 and multiplying that by 7. Hopefully that made sense. So let's go ahead. This is our final answer right here, and it's going to be 10.5 units squared. All right, so now we are in the home stretch, ladies and gentlemen. Your homework for this evening, I know this has been a long lesson, so I want to take just a moment to thank you very, very much for your undivided attention. I know you are going to do great tomorrow, and I look forward to seeing you tomorrow. So all I really need you to do this evening is numbers 1, 2, and 3. So hopefully you are able to work through those. See you in class, and as always, signing off, Ms. Rickfelder.